Hey, this is Steven from the Green Engineers, and welcome back to my 11 1/4 minute update videos. Again, I do this every 2 weeks. Today is what, the 7th, October 7th, 2018, and let's go ahead and talk about a few things. So basically, the format of these videos is just going to be kind of what I've done over the last 2 weeks. And if nothing happened, then kind of other things that have happened before that I haven't had a chance to talk about yet. Alright, so basically most of this update for these 2 weeks, we're going to be talking about the multi-struder here. So these are the module that will go onto this guy as the winder. I have all the parts now. So this is a 8mm chromed rod, just like on a 3D printer. And then here I have a dryland bushing LM8UU. Equivalent bushing RJ4JP, and you'll see here that these are actually really nice. And also, as you notice, I do not have my tripod. My brother has a tripod, so this is just gonna have to be kind of how it is. And this is really nice. Can't really hear anything. So I do really like that. So I have to make all my printer designs have this. So parts: 8mm linear rod, 8mm diameter. It's going to be about 4 1/4 inch long. After I cut it, dryland LM8UU short. Then I have a idler pulley 16 tooth, and then I have an actual pulley 16 tooth with a 5mm bore. And then here I have a 4-turn sail winch servo. And again, this guy is going to be controlled by Arduino. I'm going to talk about that in a second. And then this is just 6mm wide GT2 belt to go with these two pulleys. This pulley obviously is going on the servo, and this idler is going elsewhere to the other side of this pulley. So basically, I'm going to show you in a second what this looks like. But this weekend, last weekend I was studying for a test, so I didn't really do much. This weekend I got this guy. This guy just came in the mail. So now I have all the parts to put it together, and I've tested this guy, but for some reason this guy gets 8.5 turns instead of 4 turns. So I have only about half as much resolution, but it turns out that I get exactly about 1.5 millimeters per degree from 0 to 180 degrees. 0 to 180, that's scaled on the servo library. So I actually get 1.5 millimeters of travel over this distance, and actually with this pulley, this pulley is what dictates that, the 16-tooth pulley. And so that times 2 is 3 millimeters, so it should actually work okay, but I do want to find another solution where it has less turns. I don't know why, but it says 4 turns, but I actually get 8.5 turns. So I don't know if that means 4 turns one way and then 4 turns the other way, which doesn't make any sense. But obviously it didn't work out. So I'm going to do some more investigating on that, but as of right now, that's what it looks like. So again, that guy's going to mount where this guy is currently. And as well this weekend, in addition, so Saturday I did the code for this guy. I looked at this guy, I counted the number of turns, and then I ran a simulation of kind of how it would look when it was moving, and it all looks pretty good. Because again, this is a sail winch, and actually came with something to wind up a sail. So I just, with a Sharpie, did a mark on that, and then I did a whole bunch of math and looked at how many turns it had and looked at the resolution and did all that stuff to make sure it would work. So that guy's actually going to be mounted where this guy is right now. And I'll show you guys. I was going to do a printout, but that didn't work out. So I'll show you guys on my phone here, and I use Fusion 360, so this is the app. So let me go ahead, and then this is on my cheap phone. So as you see here, over on the left hand side we have the idler pulley, and then over on the right hand side we have the regular pulley. And then you can see that this is a 3D printed part, and it's basically the same thing as this one. It's flat on the bottom, so it's easily printed on the bed. And then you can see it has a linear rail going in between. And then this piece right here is a slide that slides back and forth. So on top, I'm going to put my little filament loop that grabs the filament and moves it back and forth. And right there attached to the pulley you can kind of see the outline of my servo. And then here you can see the servo flap popping out the right hand side. So servo goes in there and then super glued, or I'm going to screw it down or do something. And then this slider on the bottom, you can see where the top, it meets the top of the pulley kind of. Down there the belt is going to be bolted down. That's why you see the 2 holes in the top. The 2 holes in the top are for 3 M3 screws to go through there and hold the belt down with a clamp so that the belt stays tight and that it's a 2-part belt. So this guy is basically going to be glued down on the bottom. Pretty simple design, and I did some testing. It looks like it checks out with all collisions and all that stuff. So everything looks pretty good. So hopefully you guys could see that. This is a better angle. You can see the servo popping out of there, and you could see the slider, how it pops out, and then how it has a room for the 2 bolts and also the 6mm belt. Here's the back side. So hopefully next weekend coming up, this weekend coming up, which again today's Sunday, Sunday night. Hopefully I could do the 3D printing to verify this, and everything should look pretty good. And it doesn't actually look like it, but I did model the thing. I did model the dryland bushing. It is actually in there. It's just that they're both the same material, so it doesn't show up. And another thing that also really helps this project is that it is a class project now. So I have me and then another guy on my team. So basically this has to be done by the end of the semester, otherwise I don't get credit for it. So it's really pushed me forward on getting this guy developed to get it finished, because not only is my grade counting on it now, but I need it done to get all the multi-shooters out to the backers that have asked for them, and also people that have backed the have backed the extra modules. So hopefully you saw that on the screen. Just a little teaser. I should definitely have something within the next 2 weeks. It's just that this guy took so long to get here. I'm probably going to use this guy just as a stand-in, and then I'm going to find something with actually 4 turns, and then that will be perfect for this application. And then I'll actually use that guy as a real one. But it turns out that most of these housings are pretty much identical. So this is kind of the same as the last housing that I had for just a half turn compared to an 8.5 turn. So that should be, it shouldn't require much changing on the model. It should just require just to get this guy unglued with some acetone, or I just super glue, or I just hot glue this first. Take this one out, put the other one on. Should be okay. And the other one might even have, the one I'm looking at has a metal spline. So that would be even better, metal gears. Alright, so yeah, that's basically it. Sorry that I didn't have any printouts, but it looked like it was pretty easy to see on the phone. There was a little bit of glare, but that's okay. Alright, then one other project that I was talking about that I'm actually really excited about, which I'm going to get some time in next week. While the printer's running, I'm going to run to San Francisco, and I'm going to try to do this second option that I had for the reclaimer, which is my shredder, my plastic shredder. So back when Tech Shop was still around, they had Tech Shop Redwood City, and in Redwood City they had a plasma. And what I did is to design my reclaimer, the reclaimer used all 1/4-inch plate 1055 steel. So basically I bought a giant 8-foot by 4-foot by 8-foot sheet that weighed about 300 pounds, 1/4-inch thick, and I loaded it on the plasma cutter, and I just tried to get some cuts out of it, but it had too much taper. So I don't know if you know, but when you cut with a laser, a plasma, or a water jet, there's actually a V-like taper. So the top is oversized, but the bottom is undersized. And depending on how good your machine or how slow you go, depending on the machine technology you use, that taper will be adjusted accordingly. So it actually had nasty amounts of taper to where I wasn't able to slide the precision ground rod, that's the drive shaft, the square 1/4-inch by 3/4-inch by 3/4-inch shaft, into the hole in order to drive it, because the tolerances were so off. And even if I got it to fit, there was only going to be a little bit touching. So what I decided to do is the new shop, the shop.build in San Francisco, has a iron worker, which is basically a very high pressure hydraulic press, and it has a punch and die setup. So what I did is I went to Cleveland Punch and Die, who's been around for since 1880, and I got a 3/4 by 3/4 by 3/4 square punch and die with a specific tolerance that they recommended. The tolerance is actually, I think he said 32 thou per side. You can actually see it's quite a bit. So that guy, basically I'm going to load this guy into that iron worker, and I'm going to put those pieces that I need to chase the holes on, and then I'm going to punch it with this punch, and it should chase those holes. So that way I could try to get some of those reclaimers back, because I have about eight of those shredders and parts, and to get those out to people I owe those to. So I'm going to give that a shot next week and next weekend and see how that goes, and see if I could assemble a few more. Alright, so that's pretty much it for this update. Thanks for watching, guys, and I'll see you guys in 2 weeks. Thanks for watching. Take it easy. Peace.